So 1 minute, denoted by one single apostrophe, is defined as 1/60th of a degree. 1 second, denoted by one kind of quotation marks or two apostrophes, is defined as 1/60th of a minute, or equivalently 1/3600th of a degree. So an angle of, say, 30 degrees, 40 minutes, and 10 seconds could be written as 30 degrees, 40 minutes, 10 seconds. So in summary, one counterclockwise rotation is 360 degrees. 1 degree is 60 minutes, and 1 minute is 60 degrees. We could also say that 1 degree, which is 60 minutes, is 3,600 seconds. So why don't we change to a friendlier color, because I don't like writing in red, and let's convert between degrees, minutes, and seconds. So let's convert 65 degrees, 9 minutes, and 17 seconds to a decimal in degrees. And we're going to round our answer to 4 decimal places. So let's break this up. So I've got 65 degrees plus 9 minutes plus 17 seconds. And then we're going to use some substitution. I know that 1 degree equals 1/60th. I know that 1 minute equals 1/60th of a degree. And I know that 1 second equals 3,600th. Why is that so hard to say? Of a degree. So we're going to do some substitution in order to turn everything into degrees. So I'm going to have 65 degrees plus 9 times 1/60th of a degree, because it was seconds, minutes, now we're going to change it to degrees, plus 17 times 1/3,600th of a degree. We're going to plug that into our handy dandy calculator because no one likes fractions. So I've got 65 degrees plus 0.15 degrees plus 0.0047 degrees, which would give me 65.1547 degrees. Next, what if I want to convert, and here's where I showed you that we have the solutions programmed into the PowerPoints. So if I want to convert 32.479 to degree, minute, and second notation, and we're going to round our answer to the nearest second, right? You can't have quarters of a second. That doesn't make a lot of sense. So I have 32 degrees. That's my full degree part. And then I separate out my decimal part. Well, I know that 0.479 degrees times 1 degree, right? We could rewrite that as 1. And you think times 1 is itself. Yes, Bobby, isn't that so exciting, honey? So we've got 32 degrees plus 0.479 degrees, and I want to convert that to minutes. Well, remember, 1 degree equals 60 minutes, and 1 minute equals 60 seconds. So we're going to take 32 plus 0.479, hope I was doing that up here, times 60 minutes. That'll convert it to minutes. So then I have 28.74 minutes, right? But we can only have whole minutes. So now I have 32 degrees plus 28 minutes plus 0.74 minutes. Well, remember that 1 minute is 60 seconds. So we could substitute in 60 seconds. So I've got 32 degrees plus 28 minutes plus 0.74 minutes times 60 seconds. And that would give me, sorry, there's never enough room, 32 degrees plus 28 minutes plus 44.4 seconds. But we want to round to the nearest second. So my final answer is going to be 32 degrees, 28 minutes, and 44 seconds. Again, the solutions are in the PowerPoint. I know they aren't showing up with the correct math notation here. I'm not quite sure what that's happening, but that is not the case in the PowerPoint. So let's take a look at those. A central angle is a positive angle whose vertex is at the center of a circle. The rays of a central angle subtend or intersect an arc. Here we have our arc on the circle. If the radius of our circle r and the length of the arc subtended by the central angle is also r, then the measure of the angle is 1 radian, right? 360 degrees of full rotation around the circle is 2 pi radians, but that's the formal definition of a radian. So for a circle of radius 1, i.e. like the unit circle, we're building our way up to that, the rays of a central angle with measure 1 subtend an arc of length 1. For a circle with radius 3, right, the rays of a central angle with measure 1 radian would subtend an arc. Subtend means like intersect, remember? An arc of length 3. So there we are. If I want to calculate arc length, the length of an arc, I need to know the circle radius. I need to know the degree in radians, and that'll give me my S, which is my arc length. So why don't we practice calculating the arc length of a circle? I'm going to find the length of the arc of a circle of radius 4 meters, subtended by a central angle of 0.75 radians. So S equals R theta, where this is in radians, and this, oh, nope, this is in radians. And for this one, don't forget units. Units are important. So I have S equals 4 meters times 0.75 radians. So S equals 3 meters, right? We measure arc length in meters, not in radians. Here's our solutions. So let's talk about going between degrees and radians and degrees.